This video will show you 10 Python comprehensions you can and should be using. They get more and more difficult, so make sure you stick around until the end of the video. Now let's start with the basic list comprehension. So in front of me I have a basic code snippet. Now all this does is loop for x in the range 10, which means we're going to access the values 0 through 9, and we're going to append those into a new list. Now this is great. We can do this, but in Python, we have a much faster way to go about writing this code, and it's something that's actually a little bit easier to read. Now that's a list comprehension. Let's have a look at that. So what you see on my screen now is completely equivalent to the code above. What it does is use something known as a comprehension. Now in Python, we have some really interesting syntax, and one of those pieces of syntax allows us to actually write a for loop inside of a list. We can actually write it inside of a bunch of other things as well, but in this case, we'll just look at a list. Now what we do here is very similar to what we did up here. We actually say that we want to take the value x for x in range 10. Now what this will do is execute the for loop just like it normally would. We're going to get access to the values 0 through 9, so 0, 1, 2, 3, etc. But for every single iteration of this for loop, what we have on the left-hand side here, we're going to add into this list. So we're saying we want to take the value of x for x in range 10. Now, just to prove to you that this works, if I print out my values here, you see that we get 0 through 9. Now, let's say we change this just a little bit, and we do x plus 1. Now, this whole left-hand side expression here is what's going to be added into the list for every single iteration of this for loop. So let's run the code again, and notice this time we get 1 through 10. So this is the syntax. It's really not that complicated. Whatever we have on the left-hand side here is the element that we want to add for every single iteration of the for loop. Now we can have all kinds of more advanced list comprehensions, and I want to show you a few examples of those. So now we're stepping it up a bit, and we have a slightly more complicated example. Here, what I want to do is get all of the even numbers from 0 to 50. Now what I do is I write my list, I loop through the numbers in the range of 0 to 50, and then I first check if the number is even. Now to do that, I can use the modulus operator, which gives me the remainder. In this case, I get the remainder after dividing by 2. If there's no remainder, so if it's equal to 0, that means this number is even. So I can check if it is even, and then I can append it into this evens list. So that's going to give me all of those values. Now let's see how we would do this using a list comprehension. I can say evens is equal to a list. And inside of here, again, I can say number for number in range 50. Now this is going to give me all of the numbers in the range of 0 to 49, or up to 50, but not including it. But what if I want to filter for the even numbers? Well, what I can actually do is I can add a condition after the for loop. So I can put an if statement right here, even though it looks crazy and it looks like we shouldn't be able to write this, and I can write out the same condition I had before. So I can say if number mod 2 is equal to 0. Now this is actually perfectly valid Python syntax, and what we're saying now is that we want to take the number for number in range 50 only if this condition is true. So if the number mod 2 is equal to 0, then we will actually place this number in the list. If it's not, then we won't. So what I can do now is I can print out evens. We can run the code, and you can see that we get all of the even numbers up to but not including 50. So again, it looks a little bit crazy when you look at this syntax, but this is actually a really easy way to understand what's going on and what we're adding inside of a list. It's a very natural way to read this. We're taking the number for number in range 50 only if the number mod 2 is equal to 0. Now, I would argue that that's easier to read than this code right here. Some of you may disagree with me, but the reason why a lot of people love using comprehensions is because when you're populating a list, it's very clear what's going on right in the line where the list is defined. So now let's look at a few more advanced examples. But first, I want to talk to any of you that are serious about becoming software developers. Now look, it's no secret that the job market now is more difficult than it was a few years ago. However, it's still 100% possible to land a job. You just need to have the right guidance and really make sure you fine-tune every component of your application and your skills. Now that's exactly what my program at Course Careers aims to do. Not only do we teach you everything you need to stand out from an entry-level developer, but we actually walk you through optimizing your LinkedIn, setting up your resume, interview best practices, how to apply, how to reach out to people. We go the extra mile because we're really only successful if we get you a job. Now, we've already had a ton of success even in this really tough job market, so if you're considering becoming a software developer, definitely check it out. We have a completely free introduction course that shares a ton of value and goes over a high-level overview of what you need to do in 2024 and beyond to be able to land a software development role. So now we have another example where what we want to do is filter an existing list and look for all of the strings that start with the letter A and end with the letter Y. Now to write that code, we'll start by defining the list that we want to put the results in. We'll then loop through all of the strings in our options. This will go through each individual string that we have. The first check we do here is we see if the length of the string is less than or equal to 1. Now the reason I check this is that if something is only one character or no characters, then it means it can't start with A and end with Y. And I also need to check this to make sure that if I try to access the first or last index of the string, I don't get an error. So that's why I have this right here. So if it's less than one character or equal to one character, we simply continue, we move on to the next string. Down here, we do a similar thing. We say, okay, if the first character is not equal to A, then we're going to continue because it doesn't meet the criteria. And we do the same thing here. We say if the last character, which is at the -1 index, is not equal to Y, then we continue. Otherwise, we can add this string into the valid strings. Now let's see how we would do this using a comprehension. So this is one version of a comprehension we could write that would achieve the exact same goal. Now notice that I can actually use multiple if statements and I can kind of chain them on top of each other. So very similar to what I did before, I say I have string for string in my options, and then I'm checking all of the conditions that I need to be true if I want to actually put this string into the resulting list. Now the first condition is if the length of the string is greater than or equal to 2. Now you'll notice that I'm kind of doing it in reverse from what I did here, but that's fine. It's just another way to go about writing this within the comprehension. I then say if the string at index 0 is equal to A, and if the string at index -1, so the last character, is equal to Y. Now again, this is very easy to read and understand, and I've even formatted this so you can read it on multiple lines and it doesn't span out and get really difficult to read on a single line. So that's one complaint some people have with list comprehensions being difficult to read if they're too long. Well, that's really not an issue. You can actually just split it out onto multiple lines as long as you have it inside of the braces or inside of the brackets. Now what I can do is run this code and you'll see that we get the result of any and Albany. There you go. Now let's move on to a more advanced example. So now I'll show you an example where we look at a nested list comprehension. In this case, let's say that we want to flatten a matrix, which is a list of lists or a two-dimensional list. You can see that we have some lists inside of the main list. And if we wanted to flatten this, so just have one array that doesn't have any nested lists, we need to write some code like this. Now it's not overly complicated, but again, we can really speed this up and make it a little bit cleaner using list comprehensions. So here we say for row in our matrix, and then for each number within that row, we're going to append that value into the flattened list. Now let's paste in the list comprehension and see how we would do it here. You can see that it's a little bit simpler. We're saying num, and then for row in matrix, for number in row. Now the first for loop works exactly like the first for loop here. So for every single iteration of the for loop, we're going to do whatever's on the right-hand side here, which is the next for loop. And then for every iteration of this for loop, we're going to take num and we're going to add this inside of the flattened list. So if I come here and I print flattened, and I run this, you can see that we get 1 through 9 appearing in our console. I know that it can be a little bit tricky to read, but just remember that the first for loop you see is the exterior for loop, and any for loops after that are going to be interior ones that are going to run for every single iteration of the previous for loop. Now you could keep going here and you could write as many for loops as you want. That would get pretty confusing pretty quickly, but when you're only dealing with 2 or 3 of them, it's totally fine to be using a nested list comprehension. Moving on, we're looking at another example where this time we want to do something like categorize numbers as either even or odd. So you can see that I have my list here for different categories. What I do is loop through all of the numbers in the range 10, so from 0 to 9. Now I first check if the number is divisible by 2, which means it's even. If it is, I'm actually going to append the even string into the categories list. Otherwise, I'm going to append the odd string. Now, we haven't yet seen an example of how to use an if-else, so let's look at how we could use a list comprehension to replicate this example. So there you go, we now have a slightly different version of the list comprehension. Now notice that we still have our for loop here. The for loop is going to be the meat of all of these comprehensions, and you always want to be looking to the left and the right side of the for loop to understand what's going on. So we have our for loop, and we see that we're saying for x in range 10. Now what we do here is we actually check on the left-hand side what value we want to add depending on the value of x. Now in this instance, we're not actually really filtering the list. What we're doing instead is we're placing in a value for every single iteration or every single value of x. So there's no need for me to put an if on the right-hand side, which is really meant to be filtering different values. Instead, what I'm doing is picking what I'm going to be inserting based on the value of x. So I say that I want to use even if x mod 2 is equal to 0. So if x is even. Otherwise, I want to use odd. Now it's worth noting that this syntax is actually valid outside of a list comprehension. You could put this inside of a variable. You can actually write this in a lot of places in Python, but this is also perfectly valid for me to put on the left-hand side of the list comprehension. So for every single iteration here, we're going to go to the left-hand side. We're going to evaluate this expression, which is going to give us either even or odd based on this condition here. To prove that to you, I will save and run the code, and you can see we get even, odd, etc. So now let's go on to something even more complicated where we need to build a three-dimensional list. Now you can ignore the pretty printer syntax. This just gives us an output that's easier to read. That's why I'm using it. Really, we just want to be looking at this. Now in this case, what I want to build is a 5 by 5 by 5 matrix or three-dimensional list. So I want a list inside of a list, inside of another list, and then for all of those lists, I want to have values inside of them. Now we can look at this code here. We can see that we start by building the first level of our exterior lists. We create list 1. We then, for every single iteration here where we're building list 1, we start building list 2. For every single iteration of list 2, we append values inside of list 2. Then we put list 2 inside of list 1. Then we put list 1 inside of the main list, and we build a three-dimensional list. Now you don't need to fully understand it, but when I run the code, you see that we will get a big kind of array here, or a big list of multiple lists inside of lists. And you can see that's a little bit confusing and difficult for us to read this code. So let's see how we can clean it up a bit by using a list comprehension. So you can see now that we've added the list comprehension, and this immediately is a little less intimidating than this code that we have here. Now let's quickly run through it because I've done something a bit different than what you saw before. Now what we're going to start doing here is looking from the right side where we see our for loop. So the way you read this type of code is you find the first for loop that's inside of the main list. So we found that here, and you can see we have for underscore in range 5. Now you don't have to worry about the underscore. This is just what's known as an anonymous variable, and we put this in place of using something like I when I don't actually care about that value, right? So I don't actually need to know what iteration I'm on. I just want to do this 5 times. So I see my for loop, and we remember that whatever's on the left-hand side of the for loop is what's going to get added inside of our list. So what we have here highlighted is what will get added. But notice that inside of here, I've written some other for loops. I've written some more comprehensions, a nested comprehension. Now what we do is the same thing. So in the left-hand side, I need to figure out what's going to get added. So I look for the most exterior for loop, which is this one right here. I can see that it's for underscore in range 5. And then I look to the left-hand side. Now I see that I have this list, and there's another comprehension inside of here. So same thing, I go to the next level of for loops. I see this for loop right here, and I notice that for this one, I have a value num. So it says num for num in range 5, and that tells me this right here is simply going to be a list that has the numbers 0 through 4. That would then tell me that what this whole statement right here is going to be is 5 lists that all have the numbers 0 through 4. Then that tells me that what I'm going to have for this whole nested for loop here is 5 lists of 5 lists that all have the numbers 0 through 4. Now let's test it out. And when I run the code, you can see that I get exactly that. So since I just showed you something really complicated, let's go to something a little bit easier. And this is where we apply a function to a value inside of a list comprehension. Now I haven't written the equivalent code because I think this is simple enough, but I wanted to show you that it's perfectly valid for us to make a function call inside of a list comprehension. So what I'm doing here is I'm saying, okay, I want to take the square of x for x in range 10. Now notice how easy that is to read. It's so nice for me to look at this and immediately know the results that I'm getting, and it's helped by having really good variable names as well. Now obviously I could just write this as well, and I could have x to the exponent 2, but imagine we have a more complex function where we don't want to write that in one line, then obviously it's really nice to be able to call it. Now I could also use a function call in my filter, so I could say if valid, right, and then this could be some function that returns true, and I could put x. Obviously we haven't written that out, but it'd be perfectly fine for me to do that. And if I have good function names and good variable names, it makes this code really, really clean and easy to understand, and that's why we love using list comprehensions. So the next few examples I have for you are a bit of a bonus because they're not list comprehensions, but they're still useful to know about. Now the first one to look at here is the dictionary comprehension. So notice that we have a kind of list of pairs or a list of tuples. What we can do is we can use a for loop inside of a dictionary, which are these curly braces right here, and we can say for k, comma, v in pairs. Now technically you can call these whatever you want, but what this will do when you're accessing a tuple, or that's the object that you're iterating through inside of a list, is it will grab the first and the second value respectively. So the key would be a, the value would be 1. Then what we can do is simply use the syntax key, colon, value, just like you would normally create a dictionary. Now you can do some more advanced syntax in here as well. You could like apply a function to this value if you wanted to do that, or do something funky with the key, but I just want to show you that dictionary comprehension does actually exist. So if I print this out, you'll see that if we bring up our terminal, we get A1, B2, and C3, and we were able to create the dictionary comprehension. So now we move on to another quick example here, which is using a set comprehension. So just like we have dictionary comprehensions, we also have set comprehensions. The main difference is you're not going to have a key here. You're just going to have some value that you're adding into the set. Now, in order to do that, you can use the set syntax, which is this. It's just the same as the dictionary, right? So it's your curly braces. But Python will know that this should be a set if you don't have any keys, right? So I don't have a key associated with this. It knows to treat this as a set. Now, in this case, what we're going to do is remove duplicates from a list while applying a function to those values. So here, this is going to give us all of the unique squares. It's going to do that by squaring all of the elements inside of this nums list, but then adding them into the set. And since it's adding them into the set is only going to keep all of the unique values, which means if I go here and I print out my unique squares and I run my code, you can see that we only get the unique squares appearing here in the set. So now we move on to our last example, which is reserved for those of you that are really into Python and know about more advanced features like generators. Now, if you don't know what a generator is, I'll leave a video on the screen right here that you can watch to learn about it. It's super interesting and it is actually applicable in this example. So what you see here looks like a very simple comprehension, but it's actually a bit more complicated than it seems. What we're doing is using this sum function. Now what I want to do is generate the sum of all of the squares from the numbers 0 to 1 million. Now in order to do that, I would need to have access to all of the numbers, right, or all of the squares from 0 to 1 million. However, I don't actually need to have access to all of them at the exact same time. Now, the reason I'm bringing this up is because what some of you might do if you wanted to come up with that solution is you would start by generating all of the different values, right? You generate all of these different squares and you would be storing 1 million different values in memory. Now, really, that's not going to take up too much space in your computer, but it's inefficient because we don't need to have all of these values at once. We just need them one at a time so we can add them or sum them together. Now that's exactly what this example does right here and what a generator does in Python. A generator, to give you a really quick summary, only returns values when they need to be used. It doesn't store a ton of different values in memory. It will give you the next value when you ask for it and generate it on the fly. So we're not storing all of these and pre-generating them. We're only generating the value when it needs to be used. Now that's exactly what this example does based on the way that I've written it. The range function here is going to return values one by one. It's not going to generate an entire list of them. So what I do here is say for x in range 1 million, and then I take the square of that value. Now, the way that the sum function works is rather than executing this entire block right away and getting a list that contains all of the different values that we need to sum, it's simply going to ask for each value sequentially and add it to a sum that it's storing internally. So it doesn't need to know what the previous or the next square is. It just gets access to the current square that it's looking at and then adds it to the sum that it's keeping track of. So it only ever is looking at one of these values at a time, and we're not storing a bunch of other values that we're not using. The reason all of this works is because of features like generators and iterators and how some of these built-in functions are optimized. Now, when we look at this right here, the reason why it grabs them one by one is because I've kind of created a generator expression or a generator comprehension. However, if I were to actually put the list syntax here, this would completely change. Now what I would be doing is what I talked about before, where I would actually generate every single possible value or every single square in the range 1 to 1 million or 0 to 1 million and store it in a list, and then I would pass that list to sum. Now that's not what we want, so instead we want to remove this, but I just want to show you that if you were to simply add this list syntax, now you've created a list comprehension and you will generate all of these values before the sum function is actually applied. Whereas when you remove this, you're using something known as a generator comprehension, which I'm going to encourage you to read a little bit more about if you're interested in. Anyways, with that said, I'm going to wrap up the video here. I hope you found this helpful, and I look forward to seeing you in the next one.